So I'd like to now go and fix this problem. I will perhaps say that in some projects you might think one way to fix this is just to increase the size of the heap by altering that runtime value again. Now clearly that's not a good solution. In fact, it's no solution at all, because no matter how big we make our heap, eventually this application is going to run out of memory. There is definitely something going wrong here and we need to fix it. And I'll go and fix that now. Actually, I know exactly what the problem is. It's in our customer manager class. The application has a method called getNextCustomer, and this method should be removing customers from the array list, but actually it's not. It's just returning the next available customer in the list and leaving it there. So I'm going to fix this by saying, rather than returning customers.getLastProcessed, let's just remove from the array list the first item and return that. So if we call the remove method and say we want to remove the first item, the item in position 0, that will give us the customer so we can return it, and it will remove the item from the array list. Now there's a couple of other things I need to do to make this work. Rather than saying is the last process ID greater than the next available ID, I actually just need to know, does the array list have anything in it? So I should do if customers.size is greater than 0, then we can do this return. So I'm not using last processed ID anymore, but actually this is a multi-threaded application and I'm using synchronized on customers to protect my array list. So I don't want to be checking and pulling items out of the array list when any other code is also trying to edit what's in the array list. So I'm going to wrap this in a synchronized block. And it's actually the whole of that that needs to be synchronized. So I think that should be correct. Now that I've done that, I'm not using this last processed anymore, so I can remove that just to tidy things up a bit. And I think that will hopefully have fixed the problem. So let's run this again. I'm going to check the heap size. I think is still set to 50 megabytes. It is, that should be okay. So we'll set this to run. I'll have a quick look at the console first of all, before we go into JVisual VM. And well, I think this already looks better. We can see that the queue has 240 customers in it, but even though the queue has grown, the number of customers has gone down. So clearly some of those now, hopefully the majority of them, are being processed. So let's go and look at JVisual VM. We'll need to reconnect to our application. And again, go to the monitor tab, and I'm just going to remove all the graphs other than the heap graph. And in fact, I'll leave this running for a few minutes off camera and then resume recording so we can see what this graph looks like. Okay, well, I think I've left that run only for about 30 seconds, but now we can see we have a very different graph. Our 50 megabyte heap size, most of it is available. We've got some sharp drops in the memory being used, and that's absolutely fine. That tells us there's a garbage collection, and every time there is a garbage collection, the garbage collector is able to remove lots of objects from the heap. So in fact, if we left this running for a long time, we should see that the highest used amount of memory is probably going to be somewhere around about 15 megabytes. That's where the peaks in this graph are. It certainly doesn't look like it's something that is growing over time, and that's the important bit. It looks like now what we have is a very stable application and everything is working nicely. Now, I knew what the problem was in this application, but in the next chapter, I'm going to show you another tool which will allow us to find out what the problem might be and find the cause of a potential memory leak by analysing what objects are actually in the heap. So I'll see you for that when you're ready in the next chapter.